Hi, this tutorial covers the fundamental counting principle. So let's just start with an example to motivate this idea. So suppose Annie is running late in the morning and she needs to get dressed. She randomly grabs a shirt from her top drawer and a pair of shorts from her bottom drawer. There are 3 shirts in the top drawer and 4 pairs of shorts in the bottom drawer. How many shirt and shorts outfits could she wear? How many different shirt and shorts outfits could she wear? Okay, so there's a bunch of different ways of figuring this out. Let's just start with the shirts. So let's say we have shirt 1, shirt 2, and shirt 3. Okay, so if we think about if she picked shirt 1 first, okay, each of the different shorts would form a different outfit with shirt 1. So because there are 4 pairs of shorts that she could choose after she chose shirt 1, really there are 4 outfits here. Okay, shirt 2. She could either she could pick any of these 4 pairs of shorts, and that would also make 4 outfits. Okay, and same thing with shirt 3. She could end up with 4 outfits again. Okay, so since there are 4 outfits in each of these 3 categories, we would end up with 12 total outfits. Oops. Okay. So there are a bunch of different ways of figuring this out, but this was the way that we used to come up with that 12 different outfits. Okay, so like I said, this is an example to motivate the fundamental counting principle, which is a principle that states that if there are m different possible outcomes for a trial of one experiment and n different possible outcomes for a trial of another experiment, then there are m times n different outcomes if both experiments are done together. And the fundamental counting principle only applies if the outcome of a trial of one experiment does not have an effect on an outcome of a trial of the other experiment. Okay, so if we think about going back to this example again, okay, one experiment would just be picking a shirt. Another experiment would be picking a pair of shorts. Okay, so there are 3 outcomes. If we can, 3 outcomes of the first experiment, 4 possible outcomes of the second experiment. So if we wanted to know, well, how many outcomes total if the 2 experiments are done together, what we could do is just take 3 times 4 and also get 12. Okay, and again, that's assuming that whatever she picks as a shirt has no effect on which pair of shorts she picks. And if she's doing this randomly or haphazardly, the experiments will be done independently of each other. Okay, so let me also talk a little bit about a type of diagram called the tree diagram. So a tree diagram is a diagram that shows the branching possibilities of one or more chance experiments. Okay, so we could have done the outfit problem together again using a tree diagram, but let's take a look at another example here. So suppose a couple plans to have 3 children. How many possible boy-girl outcomes are possible? So let's just start by looking at the tree diagram. Okay, so a tree diagram is always going to kind of start up here at the top at a node, and then it's going to branch off into the different possible outcomes. So the first possible outcome is going to be the first set of branches represents the first child. So the first child could either be a boy or a girl. Okay. Now the second level of the tree diagram will represent the second child. Okay, so again, we'd have boy, girl, boy, boy, girl. Okay, so this outcome here would represent the older child being a boy and the younger child being a boy. Okay, if we went to this outcome here, this would represent the older child being a girl, the younger child being a boy. Okay, so right now, if we were to apply the fundamental counting principle, there are 2 outcomes for the first experiment, 2 outcomes for the second experiment. So if we take 2 times 2, we would end up with the 4 possible outcomes that we have here. Okay, now let's also do it for the the third child now. So same thing, could be boy, girl, boy, girl, boy, girl, boy, girl. Okay, so if you read this branch, oldest child would be a girl, middle child would be a boy, youngest child would be a boy. If we went to this branch here, it'd be girl, girl, girl. All three children would be girls. Okay, so what we end up with is 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Another way to get that 8 possible outcomes is just to use the fundamental counting principle, which says you have 2 outcomes of the first experiment, 2 outcomes of the second experiment, 2 outcomes of the third experiment. So that's 8 possible outcomes of these of the 3 experiments if they were all done together. All right, so that is the tutorial on the fundamental counting principle. Thanks for watching.